6.3 Day 1 Trigonometric Functions of Any Angle. In this lesson, we'll take the right triangles in SOHCAHTOA and move them in all four quadrants of our coordinate system. What that means is we'll do some minor redefining of our trigonometric definitions, and we'll have side lengths that have a negative direction, which will indicate we'll have negative answers in our trig fractions. Notice the 6 new definitions for trigonometric functions of any angle. We can utilize opposite and adjacent and hypotenuse in terms of x, y, and r. X and y are the opposite and adjacent side lengths, x being to the left or right, y being up or down. The value for r is going to be like the hypotenuse. And you can see on that picture, that would be the non-vertical or horizontal side length. Now, instead of opposite over adjacent, we define sine of theta as y over r. Cosine is x over r. Tangent is y over x, as long as x isn't 0. Cotangent, secant, and cosecant are again their reciprocals. Now, over on the right-hand side, if we're sketching a triangle in a quadrant other than 1, the location of that terminal ray, or our r value, is going to matter. That will indicate when things are positive or negative. In quadrant 1, notice all your trig terms are positive because we count to the right, which is positive on x, and we count up, which is positive on y. But then as we count to the left, notice on the left-hand side, your x values would be negative, which means cosine and tangent would also be negative. In quadrant 3, x and y are negative, so sine and cosine would be negative, but now notice tangent's positive. And we'll do a couple of examples, and hopefully that will clarify why those values are either positive or negative in the given quadrants. A couple of things to consider. Anytime you're asked to draw a triangle, you always want to connect your r value or your hypotenuse to the x-axis. Another thing to remember, we're just going to put this right underneath here, is determine your quadrant before you draw your triangle. And this will save a little bit of extra time. So determine your quadrant before you draw your triangle. So I'll say draw. Here's what I mean. In the example over on the left, it says if sine of theta equals 4/5. Now normally we would just draw a right triangle and label the opposite and adjacent side lengths. But it also says tangent has to be less than 0. So now what that means is tangent is going to be negative. And because sine is 4/5, technically sine is positive. If I use that chart over on the right, I'm going to just kind of mark when things are positive and negative. I know sine is positive in quadrant 1 and in quadrant 2, but I also want tangent to be negative. And tangent is negative in quadrant 2 and quadrant 4. So in what quadrant do those two values match, where sine is positive and tangent is negative? That would be in quadrant 2. That's where we have to draw our triangle. And here's how you do that. What we'll do is we'll just create our x and y axes. And what I'm going to do is I'm going to draw my r value just somewhere in quadrant 2, and then recognize that we have to connect with the x-axis. I'm going to draw an altitude straight down and form my right angle. Now my theta, my reference angle, is going to be the angle that connects to that x-axis. There's where theta goes. And if sine is 4/5, that means that's the y value, which is the vertical length, over the r value, which would be like the hypotenuse. And now we're asked to find cosine and cotangent. Seems fair enough, but notice both of those terms need our x value. So to figure out our x value at that bottom right there, if we do a squared plus 4 squared equals 5 squared, we've actually done this a couple of times before. That would be a squared plus 16 is equal to 25. Move 16 over, and we would get a squared is equal to 9. And usually when we take the square root, we know that a would just equal 3. But if we're going in all 4 quadrants, A could technically be positive or negative 3. Now on the left-hand side of the x-axis, even though the length is positive, the direction would be negative. So this answer is going to stay negative 3, not positive 3. And that's what goes on that adjacent side length. It isn't because the length is negative, it's because direction is negative. From there, we're asked to find cosine and cotangent. Now that we know all 3 sides, cosine of theta, if we look up at our definition, is x divided by r. In this case now, because x is negative, cosine is going to have a negative fraction answer. And cotangent is x over y. That's also going to have a negative answer. So now all of a sudden, not only do we need to remember our definitions, but some of our values will be positive and some of them will be negative. We're going to take a look at reference angles tomorrow in class.